Can the host share the screen with me? Okay, thanks. You got it. Okay, can everybody see the screen? Okay, good. Take it away, Stuart.
Well, thanks everyone for having us. We're really happy to be here. This talk is based on work that we published in Technical Communication Quarterly and presented at 4Cs, as well as some ongoing research that Johndan's doing on how designers in different disciplines work. So there'll be a piece, there's sort of a pre-publication piece in TCQ right now, but we're drawing on bits of that, but we have some new material for you as well. We're going to draw on the concept of assemblage to more fully consider the field's understandings of objects and users. Although the concept appears occasionally in technical communications work on posthumanism, the strand we're going to talk about today derives from the work of Deleuze and Guattari.
So I'm going to apologize in advance. Stuart and I are reading from prepared notes because we've been doing this forever, so we could talk for like 7 hours. So we're trying to keep ourselves on track. In a sense, an assemblage is just some objects put together like a puzzle. But in assemblages, the pieces have independent ontologies and teleologies. They have lives of their own. They're more of an informal pickup game than a coherent team. Assemblages might include pieces that are social, psychological, economic, technical, and or material. They're simultaneously simple and maddeningly complicated. They're composed of heterogeneous components. They're semi-stable. They can be made up from nearly anything: material objects, industrial infrastructures, people, communities, political slogans. They exist at different scales: the rider horse bow of the nomad, the community inhabiting a makerspace, the population of Cuba. They can nest: an army of nomadic warriors, a makerspace within a university in upstate New York or central Pennsylvania. The 2003 power blackout that affected 50 million people across Northern America can be understood as an assemblage. The blackout included an electrical grid composed of, as Jane Bennett puts it, quote, a volatile mix of coal, sweat, electromagnetic fields, computer fantasies, electron streams, profit motives, heat, lifestyles, nuclear fuel, static, legislation, water, economic theory, wire, and wood, to name just a few of the actants, end quote. Going on to quote Latour, Bennett characterizes the blackout as involving, quote, a slight surprise of action in which there is no object, no subject, but there are events. I never act. I'm always surprised by what I do, end quote. So an assemblage, even of concrete physical objects, pulls in aspects of the social, political, and cognitive. The emphasis on change and flow is evident in our epigraph. Deleuze and Guattari noted how a nomadic assemblage, person, horse, bow, functions as a heterogeneous semi-stable unit. The nomad machine operates fluidly, contrary to that of the traditional ordered phalanx. In Deleuze and Guattari's terms, conventional armies operate in gridded or strided space, while nomads rupture the grid, operating in smooth space. As assemblage theorist Emmanuel Landon says, the nomad demonstrates heterogeneity, quote, cutting it as it does across entirely different realms of reality, the personal, the biological, and technological, end quote. Deleuze says that assemblages scale in semi-stable groups, nomads in groups and nomadic armies that can rise up in campaigns and then disperse back based on changing contexts and needs.
Deleuze and Guattari's concept of rhizomatic and arborescent are also useful here. Arboreal structures are tree-like or hierarchical. Each part is fixed within the structure. Rhizomes, however, are networked and contingent, emerging at surprising points. Rhizomes are where innovation happens. As gridded space smooths out, structures loosen, opening the possibility for reassembly into new forms. Quantitative changes become qualitative changes. For example, water at sea level pressure remains solid as the temperature rises from -10 degrees Celsius to -1 degree Celsius. As the temperature crosses 0 degrees Celsius, water becomes liquid. A parallel transformation takes place as water moves across the 100 degrees Celsius mark and turns to steam. Innovation in assemblages occurs when elements cross a phase state boundary. In earlier work, we discussed the routine use of templates in website design. Templates allow even novice users to deploy professionally designed websites filled with their own content. Use of templates often carries with it negative connotations, something novices rely on, like training wheels, because novices lack the skill or creativity to make something original. Although that may sometimes be true, the interpretation mystifies creativity.
So in reality, professional programmers often draw on pattern and code libraries. They use these libraries as building blocks to avoid writing original code. I want you to meet Andy and Lee, two app developers who worked at Dragonfire Technologies, a small agency in Potsdam, New York. And by small, I mean it was just Andy and Lee. I met with them for a series of interviews over the course of a year where they explained to me their work processes and structures. In this video clip, they describe how they've developed a core smartphone app that can be redeployed with different surface level features for different clients, which improves how fast they can finish each project.
In my mind, is easy to write, it's easy to maintain.
Yeah. Sorry, I need to optimize my video or screen for video. Sorry. Okay, try this again.
In my mind, is easy to write, it's easy to maintain. The next big leap is, okay, you can hire me for a project and Kelly can hire me for a project. The innards, you might not be able to tell the difference between the innards, right?
Right.
Functionally, and it's going to work beautifully, but then looking at the two sites, you would never guess in a million years that these are the same code that's running these two. You might have a completely different set of requirements that make us go down this path. Mm-hmm. Kelly has a set of requirements this path, and as long as we can make them look the same, unique, and you feel good that you have a unique product visually, mm-hmm. I don't think you care that the code in the background is the same, as long as it works.
So that's the holy grail, that we want to get out of the R&D business and get into the assembly business.
So for these developers, code reuse is not a weakness or training wheels, it's a goal. Although Lee means assembly business in a primarily functional sense, each application is an assemblage in the broader sense we've been discussing. It's a semi-stable collection of heterogeneous elements in specific contexts.
So object-oriented ontology, or OOO, helps us apply our notion of assemblage in technical communication. Ian Bogus defines the central orientation of OOO. OOO puts things at the center of being. We human beings are elements, but not the sole elements of philosophical interests. OOO contends that nothing has special status, but that everything exists equally. Plumbers, cotton, DVD player, sandstone, for example. OOO offers the ability to move away from human-centered stances that prioritize mythical free agents. At the same time, it avoids making non-human objects free, autonomous agents. At the start of the personal computer era, the stable assemblage of person plus adding machine was deterritorialized. The nested assemblage of the adding machine, case plus keys plus paper roll, slowly took on digital elements. The fluidity afforded by the evolving machine deterritorialized the larger assemblage. A qualitative change transformed into user plus computer plus application, capable of much more than adding and subtracting numbers. To return to the 2003 power blackout that Johndan mentioned, the blackout also represents a scene for OOO. This massive blackout resulted from a cascading and difficult to understand constellation of events, loosely but inextricably related, acting as an assemblage. Electricity itself, power plants, transmission wires, energy corporations, energy consumers, and the Energy Policy Act of 1992. This assemblage, composed of many smaller assemblages, illustrates the complexity of agency while making it clear that simplicity is a futile goal. Much work in posthumanist technical communication acknowledges the perils of decentering, effectively demoting humans. Andrew Mera cites Bell Hook's critique of postmodernism in general. We should indeed be suspicious of postmodern critiques of the subject when they surface at the historical moment when many subjugated people feel themselves coming to voice for the first time, end quote. So we tread here cautiously, considering possibilities while being mindful of dangers. If none of us have sole agency, we all have some agency. Assemblage theory and O are complex philosophical discourses. And usefully for our purposes, they are both intensely material. In his work with O, Bogus describes his considerations of philosophical positions with carpentry, a term he rearticulates to the act of exploring philosophical concepts by making things. Bogus suggests that making things is a way of working with philosophical lab equipment. Johndan and I propose that makerspaces afford similar functions in technical communication, helping us test theories and explore praxis. Makerspaces are assemblages that include higher education and technology development, crossing a phase-state boundary, deterritorializing education. These transdisciplinary, contingent, and fluid spaces are where nomads work within assemblages of innovation, community, and technology. We're translating usability theory to pedagogy by positioning students as users. Like many university makerspaces, the makerspaces at Clarkson and Penn State house a varied collection of technologies: electronic building blocks, programmable robots, microcontrollers, single board mini computers, programmable sewing and embroidery machines, CNC cutting tools, soldering stations, and 3D scanners and printers. Affiliated computer classrooms have software including Adobe Creative Cloud, Final Cut Pro, and Microsoft 365, as well as technology for recording and editing videos, podcasts, and music. Large screen displays and projection systems support tutorials, meetings, and presentations. Furniture is reconfigurable depending on group needs, with whiteboards, markers, butcher paper, Legos, and the ubiquitous Post-it notes used for design thinking and other innovation work. Often housed outside of or across traditional academic boundaries, makerspaces are assemblages where nomads work. Academic departmental assemblages are invariably gridded, striated, and structured by rank in rigid hierarchy: the arboreal full professor, associate professor, assistant professor, graduate and undergraduate students. Certainly, this system of traditional academic structures provides continuity, knowledge replication, and evaluation standards. But the system also, by necessity, channels innovation into prescribed categories: grant funding, peer-reviewed journal articles, monographs from university presses. The academy exerts power by fixing meanings into hierarchical categories, territorializing the assemblage. Anyone who has worked in makerspaces recognizes their chaotic or deterritorializing nature, with users drifting in and out, 3D printers spooling filament into prototypes, exhaust vents whirring above soldering stations, voices crisscrossing in informal tutorials. Although makerspaces sometimes function as production labs for traditional academic work, their defining features create possibilities for new nomadic assemblages to emerge, oftentimes spontaneously. Of course, makerspaces are no more immune to the politics of technology than any other environment. As the field explores the possibilities of makerspaces, we should all be mindful of how they can exacerbate problems of diversity, equity, and inclusion. In a review of 150 research articles, Shannon Merson identified several authors who contend that makerspaces promote white privilege, are male-dominated, and widen rather than shrink the digital divide. We raise these concerns to avoid the impression that we find makerspaces to be educational panaceas.
Okay, we want to use a university student competition to help us apply our assemblage theory to technical communication. At Clarkson University, the President's Challenge annual competition asks teams in 2019 to, quote, envision how the Internet of Things can make your community a better space. So student teams were given a box of Arduino gear and a small budget for purchasing additional materials. The technologies in the box offered provocations to the students. The possibility of internet access suggested rhizomatic shoots, possible connections waiting to be made. In this clip, student Brian Penny and his team describe how a focus on the Internet of Things opened up new possibilities for objects.
Oh my goodness, this is actually a really cool design for more than one group of people.
Yeah, I think it's interesting. Who had this initial design? That's unanimous. Okay. So where did you get the idea from?
So one night, we actually had like a research assignment prior to the whole project in our first semester. It was just like a background research of the Internet of Things, and that just got me thinking, and I just kind of went on like this mental tear, and I was just like, what are all these things I can connect to the internet? And I came up with like ideas like a toothbrush or like glasses or like a coffee maker connected to you, like your alarm clock or something, and then this one came up, and just the group like this one, so it worked out.
Yeah. So Brian and his team began thinking like an object. What does the Internet of Things want? What does a toothbrush want from the internet? Assemblages form as individual elements pull and push at each other. For the students, the Internet of Things provided an impetus for imagining different assemblages. The President's Challenge defamiliarized objects, coffee makers, glasses, alarm clocks, by suggesting that these objects were no longer isolated, but instead wished to be connected to other objects. The space of possible assemblages over time, discussion, and experimentation started to crystallize.
So what we call it is GP sneaks. It's like a navigational system within the sole of your shoe. So like I want to say like the two things in the middle of the foot, like where your arch would be, is those are two vibration emitters, and what that does is it's connected to a Bluetooth thing which is down by your heel, and once your heel is in, it like sets off like this little switch, and then that's what turns it on, and then you can connect it to your phone or a mapping service, and then the vibrators will vibrate which way to go. So your right foot would vibrate if you need to take a right.
Oh, it's a
or your
directional.
left foot would vibrate for your left.
That's interesting. I thought you were going to tell me that it was just told you where you were on a map, but it's actually giving you input.
So you could plug in like to Google Maps or like the Apple Maps on your phone, and like whatever way you need to go, your shoes can take you there.
They also had a large round conference table that sat next to. Sorry, we're just skipping ahead. I want to return to Dragonfire in order to discuss another type of assemblage, boundary objects. Boundary objects are a loose category of collaborative work artifact, first described by Susan Lee Starr and James Griesmer in the late 1980s. Boundary objects are those shared. It's autoplaying. Boundary objects are those shared collections that help groups of people coordinate activities. A map of a local woodland, for example, can be used by different people for differing purposes. A father looking for a trail to take his daughter hiking, a biologist looking for lowlands in which a rare salamander might live, a cyclist looking for a steep drop to take their new mountain bike on. So start to find some boundary objects have interpretive flexibility, they're heterogeneous, and they can exist at different scales, so they share a lot of characteristics of assemblages. Dragonfire's office was filled with boundary objects, both physical and digital. In work I published earlier with Eric York, we analyzed the ways in which Andy and Lee used a large portable whiteboard in this scene to structure specific projects. They leave the board out in front of their desk to refer to during meetings and individual work, and they'd update the board periodically to account for the new facets of emerging understanding. They also relied on digital boundary objects for different purposes and groups of users, including Jira, Trello, and GitHub. For STAR, Jira would be something of a scaling up of looser tools like whiteboards. As boundary objects scale, their characteristics become more formal and less ad hoc. In a sense, they're moving from smooth space to strided. Interestingly, in addition to Jira, Andy and Lee also use Trello, which is a similar application published by the same company that publishes Jira to track projects. The two applications, unfortunately, do not share data. They were not originally developed by the same company, but because Dragonfire clients struggled to understand the complex Jira interface, Andy and Lee manually transferred data back and forth between these two boundary objects. They both possessed an inherent understanding of the importance of these different boundaries. In effect, a boundary object is an assemblage that includes both material or digital objects as well as its community of users. Over time, many of the boundary objects at Dragonfire began to include me as I tracked, for example, how tasks move from location to location, or I photographed an evolving whiteboard. Boundary objects are semi-stable, and this feature is crucial because they're somewhat open to change or different interpretations, but not completely open. We don't want to romanticize smooth space or nomads. Innovation happens in the oscillation between fixity and openness. Without some stability, you just have a box of junk. Student collaboration, without exceptions among the undergraduates I interviewed, without some stability, you just have a box of junk. As Eric and I observed, students, especially at the undergraduate level, do not maintain boundary objects. There are several reasons for this. The first reason is probably obvious. Boundary objects emerge in the context of large, complex, collaborative projects. A student work on a small individual project would gain a little from the maintenance of a boundary object. But even when students take on larger collaborative projects, we often don't provide them with tools or space to create and maintain boundary objects. Let's skip back here. So, for example, in a UXD class that Eric taught several years ago, teams spent several weeks in the planning and prototyping stages for a website using the ubiquitous Post-its to map out the structure of a relatively large, complex site. The Post-its remained on whiteboards from class to class, allowing teams to maintain their shared understanding across an extended time frame. You can probably see where this is going. One evening, a student worker, not understanding that these messy collections of scribbled notes were useful, thought they were trash and put them in a recycling bin. Not surprisingly, the student teams resisted the idea of recreating new boundary objects after this event. Now, I've had some success in helping students create digital boundary objects using collaborative applications like Mural, but I've also seen the need to spend more time explicitly talking to students about how boundary objects work and why they're important. Student collaboration, I think I recorded this accidentally. To return to the President's Challenge, all the teams I've worked with used a shared Google Docs file for their technical reports. So here's the technical report that Brian's team completed. Like the other teams I worked with, Brian's team ignored the useful teamwork support features in Google Docs that might have helped them create a boundary object. They simply shared a single linear, simple document in which each student worked in relative isolation on a single section. There was little substantive revision, no margin comments, no revision notes. They appeared to be simply filling in buckets. So in effect, GPS Sneaks is an assemblage that's constantly at risk of dissolving into smooth space of individual work. The heterogeneous elements drifting off in their own direction, each student acting more as an agent than as part of an assemblage.
So what we see here is an interesting contradictory set of stances. Users are individuals who have agency. Communities are groups that have agency. Technologies are objects that have agency. Shoes are no longer simply protection, although certainly they were never that simple. Shoes have agency. They can take you there, as Brian said. In assemblage theory, though, each of these, users, communities, technologies, are assemblages, interconnected, contained within one another. As we've noted, assemblages exist at differing scales. A photoresistor, a third-year business student, a group of students in a meeting room huddled over a 3D printed insole, breadboard, Arduino, and computer. Assemblages have their own agencies, different than any individual component. Assemblage theory helps people theorize and practice these instances, recognizing how one informs the other. By refusing to allow a single scale to dominate, people can push at different areas of the assemblage, understanding that their agency is not so simple, not a yes or no thing. So to imagine how our assemblage theory works within the history of technical communication, consider some of the ways the field has structured different types of relationships between objects and users. Historically, we've neglected users by constructing them as simply a component of a system. We've observed users by making them part of a human-computer dyad. We've contextualized users by acknowledging that their environments are constitutive when it comes to meaning making. And we've involved users, as in participatory design, constructing them as producers. Now, consider how each of these perspectives would understand the GP Sneaks assemblage that Brian and his group created. There are many ways we could frame the group's activity, but as educators, we consider the activity in terms of teaching and learning. In terms of neglecting users, a traditional approach to the assemblage of GP Sneaks would simply construct students as receptacles. The GP Sneaks team would be less a team than a class of passive students. Learning how to program an Arduino would begin with traditional lessons on electronics and programming. Students would take notes, memorize the color codes used to identify different resistors, and then take exams to determine if they had learned the material. In terms of observing users, as the focus moves towards students, affording them agency, education might involve a hybrid model with some elements of lecture, but also providing students with the technologies themselves, asking students to build simple interactive devices with Arduinos. As instructors watch students populating breadboards and coding, we could alter elements of the lecture and activities to make learning easier and more effective. In terms of contextualizing users, here instructors begin to observe what goes on around and within students working in the makerspace. We would look at the broader ecosystem, how learning about an Arduino relates to their other classes. We ask students to explain their processes for understanding how the pieces fit together. We watch them troubleshoot connections. We consider how they fit this work within the short blocks of time they have in the makerspace. And we examine how they carry work and knowledge from one session to the next. In terms of involving users, as students gain higher levels of agency, instructors can bring them into curriculum and lesson planning. We discuss what types of things they might want to use Arduinos for. We might let them choose a different platform. Teensy, Raspberry Pi, and Daisy are similar to Arduinos, but offer different capabilities. Daisy, for example, affords construction of electronic music technologies, such as sequencers. Finally, in terms of decentering users, the flattened ontologies of posthumanism help instructors recognize the multiple agents involved in student projects. Clarkson University's makerspace forefronts working with material objects, circuit boards, solder, and resin. Digital work occurs primarily to make concrete things. Students wanting to work with video equipment are shunted to less visible rooms, which are not used as frequently as the main makerspace. As we'll discuss below, the current makerspace assemblage at Clarkson created some issues that resulted in small deterritorializations in order to construct new assemblages. As the president's challenge itself has recognized in years, institutional politics and alignments from one major to another provide greater opportunities to some students than others. More recent challenges, therefore, have de-emphasized technology to encourage more interdisciplinary work. So in terms of the nomadic users that we've been talking about, the GP Sneaks assemblages help us rethink agency as always partial, and sometimes out of control or agentless. In our version of assemblage theory, openness to working at different scales and in oscillating degrees of territorialization encourages us, teachers, students, insoles, Arduinos, to take differing perspectives. We would learn to think not merely from the perspective of other humans, but of objects, networks, and assemblages. As Johndan notes, knowing how is embodied knowledge, but it is also flexible knowledge, because skills learned in one context can be adapted to other contexts. It is this flexibility that gives the workshop, as an emergent whole, its capacity to deal with variation in materials, procedures, and products, end quote. So generally speaking, traditional education prioritizes declarative knowledge, while makerspace education prioritizes procedural knowledge. The loose apprenticeship model on which makerspaces operate contrasts with the factory worker model. The former is more open to deterritorialization and change. The latter is so highly territorialized that users of equipment must adapt to it.
So object-oriented ontologies ask us to think like objects, decentering ourselves or flattening the normal hierarchical ontologies that put humans at the top. Boggess describes this move as thinking by analogy. To illustrate this, Boggess draws on the analogous performance of film cameras and common digital cameras. Quote, when a photographic emulsion is exposed, the photons focused by an optical device hit its surface all at once, and silver regions are created all over the emulsion at different intensities, producing a faint image. A digital charge-coupled device, a CCD, works in much the same way as a film emulsion, although in the place of the silver crystals, a CCD is covered with many light-sensitive cells that record the individual pixels of an image. So the analogous relationship between the two technologies affords an understanding of how images are created in each: light, exposure, translation. In low light conditions, recording a very high ISO, beyond the working accurate range of the film or the sensor, noise is introduced into the system. Although there are many differences between film and digital cameras, analogical thinking can help users understand how both types of cameras operate. Often, without realizing it, photographers learn to think like film or learn to think like CCDs. In assemblage theory, working with an Arduino affords the same sort of analogical thinking. In electronics, for example, voltage, resistance, and current are often explained by using water as an analog to electricity. Electrical circuit functions like water in the pipes of a household. From this perspective, the diameter of the pipe represents current in amps, the water pressure functions like electrical voltage, and friction or blockages in the pipes act like electrical resistance. This analogic thinking helps newcomers who understand water use analogical thinking to understand circuits and plan, implement, and debug projects. But assemblage theory can also help users map that learning into domains that are not analogous. For example, a sketch, which is Arduino's term for a small program, can send or receive a signal to or from a digital pin into various components, such as an LED. But while electric voltages can vary continuously across a range for the Arduino, 0 to 5 volts, the digital pin sees only two things. It's a gate. It's either on or off, low voltage or high voltage. One of the first sketches that many users learn is how to blink an LED at on and off at varying rates of speeds. So users need to consider the difference between seeing like a human and seeing like an Arduino digital pin. Arduinos, like most computers, can act and perceive very quickly compared to humans. Arduino time is measured in milliseconds. The typical simple blink sketch has to explicitly slow down the Arduino's behavior by orders of magnitude for the blinking to be visible to humans. At higher rates of speed, the LED does not appear to blink at all due to the persistence of human vision. So users can implement a technique called pulse width modulation, which varies the relative time between off and on for an LED. So here, for example, at 5 volts on all the time, the LED glows brightly. At 0 volts, the LED is obviously blank or dark. But if you oscillate the on and off times to more or less of each, the LED gets dimmer or brighter in the way that it is cycling through the sketch here. So to understand how to fade an LED, users have to negotiate the contradictory needs of digital pin 9, which expects a binary signal off or on, as well as the human desire to see light grow slowly brighter or dimmer. So bridging that gap requires acknowledging a failure of the human's visual system and a willingness to think like a digital pin. Or to be more accurate, learning how to think like digital pin 9, learning to think like a human. What's it like to live so slow? What it's seeing like when your senses are so dull? This hack corresponds to a similar move Bogos makes in his discussion of film and digital cameras. Most photographers are familiar with the results of pushing a camera's ISO too high in low light conditions. It creates noise. This noise is due to the specific sensor in a CCD. It's called a Bayer sensor. It's the most commonly used sensor. Other sensors, though, such as this foveon sensor, are not as susceptible to low light degradation. Foveon sensors are able to perform at much higher ISOs without noise in the image. However, in a foveon sensor, as ISO increases, image colors shift, greens fade, and reds become yellowish. To most photographers, this color shift seems like an error. But as Bogos argues, this shift is true to how the sensor sees. Unlike Bayer sensors, foveon sensors include 3 layers of silicon, 1 per primary color. In low light, the signal strength decreases as photons travel through successive levels. This decreases what appears to the human eyes as a color shift in the resulting image. But Bogos draws on a different analogy to help us think like a foveon sensor. Human vision at dusk or dawn, which is called mesopic vision. In humans, we use different cells depending on the luminance of the environments. Rods which are used in dim light, primarily register green and blue light, but not red. This translates to the grayscale we see in very dark conditions, scotopic vision. In bright conditions, our eyes rely on cone cells, which have variants that work well with blue, green, and red, photopic vision. But at boundary conditions, both types of cells are working simultaneously, causing us to see both a monochrome and color at the same time. In a sense, then, a foveon sensor's color shift corresponds to mesopic vision in humans. Perspectives like this afford opportunities for students working with unfamiliar objects, combining them and troubleshooting them. The flattened hierarchy and ad hoc organizing and focus on tinkering and hacking encourage new ways of thinking about object-user relations. So this sort of thinking is probably more common than we realize. In interviews with experts in a range of fields, including the developers Andy and Lee, but also in a series of interviews I did with Jared Sommerfeld, who's an associate professor of electronic music at SUNY's Potsdam's Crane School of Music. So during one interview,
and this will be panning all over the place. This is going to go through the owl and be panned, but I'm just going to kind of bring in all the voices.
percussion.
Yeah.
We'll pause this. During one interview, we talked about a piece he was developing, a modular synth that would be accompanied by one of his graduate students who's going to be playing improv using a horsehair violin bow that he bought on Amazon to play the strings of a piano. So in this section, Jared is performing some of the synth parts. I should give you a sort of public service announcement. Be careful about what you decide to research, because after I interviewed Jared several times, I went out and bought about $5,000 worth of modular synths that I can barely play. So I'll go back to this. The difficulty that Jared said involved the fact that he was not going to be present performing live as half of a duet. Instead, Jared wanted to record his piece ahead of time and send it to his student as well as other performers who could play back the piece while they played along with it.
Okay. The very first thing I do when I go to perform or have something played is I tune the bass drum sound to get the most resonant possible kind of deep, dark tone that I can. And so I never know what note that's going to be or what frequency it's going to be, because it was much different at the space in Jacksonville, and it's like much different in my office, like this tiny little space. So I don't know what that's going to be yet. So it's going to be my job to find a way to EQ and do everything in the audio workstation that it's always going to be that punchy, kicky kind of bass thing.
We just work around that.
I have to work around that because ideally, yeah, if I was playing live, I could go early and tune all my drums so that they're going to sound amazing.
Yeah.
You know, you never even know like what speakers you're going to get
Yeah.
for a space or anything. So that'll be the next challenge, but that's, you know, not anything I haven't seen yet, you know.
But you said you haven't worked with a piano and electronic. So I should contextualize this a little bit. Jared's office looks kind of like a concrete bunker. It's in the basement of a building, and all the walls are literally concrete blocks. So the acoustics of this room are going to be very different than anything where he's going to perform or the piece will be performed. But Jared, like any rhetorically sensitive designer, understands that the piece is not just a piece. Instead, it's a component in an assemblage. Other components include not just the live performer, but the architecture itself. You there, Stuart?
Yeah.
Okay.
Okay. So I wasn't sure if you had more video. Okay. So to sort of pull this together here, if makerspaces provide contexts in which traditional hierarchies can be disassembled, in that breakdown, users may find themselves decontextualized, scattered. Assemblages, after all, are not atomized pools in which every element is as important as another. As our theory posits, innovation happens in and around flux. An assemblage is a semi-stable, heterogeneous collection. Breaking down hierarchies is only one phase, a necessary one that must be followed by coalescence into new assemblages. Focusing exclusively on how makerspaces break down hierarchies fails to account for the nature of work in complex sociotechnical contexts. Students working on Clarkson's President Challenge lacked robust processes for writing the feasibility report or shooting and editing pitch videos, two of the requirements for the competition. Video projects often appeared unplanned, hastily shot, often on smartphones in portrait mode, and only lightly edited. Their collaborative writing processes were extremely straightforward, with little planning or substantive revision. Writing processes were not discussed explicitly in the challenge materials, and students did not appear to have any explicit education on collaborative writing. And we shouldn't romanticize the metaphor of the nomadic warrior. Most of the teams were nomadic in that they didn't have a stable, semi-permanent space in which to meet. Meetings occurred in different classrooms, dining halls, and meeting rooms. As such, teams didn't have the opportunity to create boundary objects, the shared physical artifacts that provide continuity and support for complex tasks. So while the flattened ontologies of makerspaces break down often limiting hierarchies and provide new possibilities, these flattened hierarchies can also remove important support and stability, as well as access to learning resources, such as experts who can teach new skills. As a counterbalance to the contingency of these nomadic spaces, Clarkson's Makerspace offers a one-credit course during the President's Challenge to provide not only technical skills, but also a rhetorical education in ideation, making, video production, and writing. Much of this instruction occurs in workshops rather than lectures or readings, a hybrid of makerspace and classroom. The goal of such instruction is to illuminate and leverage the recursive nature of functional and conceptual knowledge. This goal can be accomplished by re-territorializing pedagogy, but in a manner that integrates the functional knowledge needed for makerspace projects with conceptual knowledge from the field, focusing both on why and how to do things in specific situations, rather than simply on how to use the available technologies to make something work. So we wanted to end there with some of the challenges of working with our theory, and we certainly don't want to glamorize it as some kind of unproblematic lens in which to work, but rather a lens that can open up some new possibilities and some new problems. Thank you.
So Joseph had a question and wanted to know whether or not we were asking Penn 9 to consider the audience or just the composer. So one of the issues of thinking like an object is it's obviously just a rhetorical device. You can't go through life thinking that everything is equally important and that we're not important. But in terms of something like Digital Pin 9, we're asking the composer to think like, as I think I said, to think like Digital Pin 9, learning to think like a human, which defamiliarizes ourselves and lets us think of how others might see us, including Digital Pin 9, but also other users.
I think we do this kind of thinking in a low level way, in a kind of a mundane way all the time. If you just think about like technical standards, like none of your stuff works together. Can't share files.
It can't play PowerPoint.
Yeah. Can't really do anything unless you, understand how standards, various kinds of technical standards make your kind of ecosystem work. And so I think we do this kind of thinking all the time, sort of unconsciously. And, once we start connecting things to the internet, for example, things get a lot more complex. And I do think, as opposed to simply, we're very good about thinking about audiences, and purposes. What does our audience want? So we're simply adding really more questions to our audience analysis heuristics is really what I think what we're doing ultimately. Understanding that, humans aren't the only, understanding what humans want isn't the only kind of audience understanding that you can have when things get as complex. This is really about the complexity of technical communication. When Johndan and I, Jason and others, when we went through graduate school, I would argue things were complex, but our sense is things are increasingly more complex. And the field spends a lot of its time trying to figure out how we can manage that complexity. And so we're kind of thinking about additional audience analysis questions and different kinds of institutional and organizational questions.
Yeah, I mean, so to go back to that, one of the things I think this whole thing is useful for is helping students understand different audiences. So for some, especially if you work at an engineering university like I do, a lot of the students are not, they're not very socially adept. So getting them to understand how an Arduino thinks may, for some of them, be easier than getting them to understand how a user thinks. And that's sort of to them, I think, a step towards gaining that sort of audience awareness.
I don't see any other questions in the chat, but does anybody have another question or addition or comment or disagreement?
Can I ask a quick follow-up question, Johndan and Stuart? Thank you. I think this is really helpful to think through a lot of things, especially in the local innovation space, right? I think both of your two cases, one is an IT company, the other is a makerspace. So thinking about the assemblage, how the assemblages work locally. I have more like a follow-up question. So I know assemblage analysis can be applied to look at larger scale, right? Events, for instance, how would you operationalize the approach you have now if we want to use assemblage to analyze pandemic, how we deal with COVID, right? Internationally, nationally, in the state, so more like a macro level analysis. How can we make that work? Thank you.
So I think you can, because the assemblages scale, you could do this by looking at sort of how different institutions respond to COVID. Like at my own institution, Clarkson, we're fairly remote. We're really remote. We're like 9 hours north of New York City. I can see Montreal, the lights of Montreal on the way home. So when students went away on break, that was considered a period where they were going to bring more infection back. So during the first week after breaks, Clarkson did a lot of work on testing and on booster vaccine, things like that. You could scale it up to look at so you could do that at different institutions and find out how they responded to things. You could also look at sort of nation states in the different ways that England has responded to COVID, the United States, Canada, Mexico, things like that. So I think you could scale this all the way up or down for each sort of type of institution you wanted to look at.
That's one of the reasons we used that blackout example. That was a large scale event, but was not locally rooted at all, and very difficult to understand causality. That's one of the things we're not giving up on causality, but things do happen for reasons. But sometimes our analysis is too simple, and sometimes our attribution of agency is too simple, and that obviously conflicts with working in an institution where a university where we count on the ability to do that, right? That's the territorialized version. In order for a graduate student to successfully defend their dissertation, we want to be able to say, we want to be able to assign agency to that project. So these are, we're not saying that's, we tried to be careful to say that actually assemblage theory requires territorialization. It has to, you have to have stability in order to do things. But when things are overly stable, then that's when innovation can slow down, and when we can think in too simple terms about things like causality and agency, which are there will never be a final word on agency or causality. So we're just trying to think about what the next words might be about those very, very complex ideas.
Wonderful. Thank you so much.
Well, thanks again for having us. And if anything occurs to you later that you'd like to follow up, please do. And I'm jealous. I wished at Penn State we had such a large organized group of TechCon people running a conference. So bravo for that. We looked back through some of the older conferences materials that are up on the web. Very impressive. So nice job, everyone.
Yeah. Thank you.